afternoon, everyone, and thank you all for coming for the Lundin-Snider seminar series, for which today we have Clara Balasko from BHP. We'll have a few words of introduction, and then she will start her presentation. So Clara Balasko is a civil engineer with 19 years of experience. She obtained her bachelor in geology from Texas A&M University and her master in geological engineering from the University of Nevada in Reno. Before joining BHP 3 years ago, Clara worked as a consultant on various field engineering projects in America, Australia, and Asia. Today, Clara is the acting head of planning and technical for BHP Legacy Assets, which manage 23 sites in various stages of closure across Canada and the United States of America. So, Clara, thanks for accepting the invitation, for being here today, and the stage is yours.
Yeah, sure. Thank you all for having me. I will say one correction, since I sent that to you. I am now the head of planning and technical, so no more acting. Don't have to pretend to do a job anymore. I actually do it. Sure, so... Oh, button. There we go. So... I'm going to be talking to you guys today about some of the work that we're doing within our legacy assets group within BHP to manage some of our sites. I want to thank you all for having me, and I want to thank Kate Somerville. I want to give some credit to Kate Somerville, who's our general manager for BHP Legacy Assets, Brian Ayres, who's our new manager of integrated closure planning, as well as Kim Ferguson, who's our resource center of excellence within BHP for closure lead. They've did some heavy contributions to this talk, and I just want to give some credit where credit's due. So within legacy assets, we have a little bit different view on mining, because what we do is manage non-operating sites. So what we're trying to do is reimagine our legacy of mining, to create a positive story from mining, to change some of the conversation and the perception of mining within the world. And I think as we move forward, and as some of you move forward into your careers in mining, or some of you may have been in mining for a while, but we want to ask ourselves, if you knew the mine that you're working at or that you're planning to build was going to be operated by your company in perpetuity forever, would you make different decisions as you move into the planning, as you move into the closure, as you move through the operation? There's 3 key messages I'd like people to take away from this talk. Relinquishment of mine sites is a great aspiration, but I don't know that we've ever really seen it happen well within the US or Canada, really. There's not a lot of examples of it happening, so we need to plan long-term when we're developing and operating the sites. We need to make decisions based on risk, a risk to the sites, and how we can build value with the sites, instead of just meeting regulatory minimum for what we're being asked to do. As well as robust mine closure planning really requires collaboration across a wide array of disciplines. We're looking at not just the technical disciplines, the hydrogeologists, the geochemists, the geotechnical engineers. We're also talking about working with our corporate affairs teams, with our environmental biodiversity teams, with indigenous stakeholders who are external stakeholders, stakeholders external to the business as well as internal. The communities that we operate in, what do they want this place to be at the end of operation? Because if we work with them and develop a good vision, then that can carry into the future if we're serving more than one purpose with that mine. So with the value of hindsight, we're operating, here. Let's go through. This is a little disclosure. Nothing I'm making is forward-looking sites. Don't take anything I say as go buy BHP shares or anything. So I have to put that in there. Okay. So with BHP portfolio, with our portfolio, we're managing 23 non-producing sites across the US and Canada. Most of these sites, BHP never operated. What we did was go out and BHP bought a company to get a mine over here, and it came with all of these liabilities that was attached to it. I think of the sites that we operate, maybe one was operated by BHP. All of the others were acquired through acquisitions and mergers at various times throughout BHP's history. The Legacy Asset team comprises about 200 employees, contractors, and we're stewards of these 23 non-producing sites. And the reason we call them non-producing is because they are being operated. We have operators on site who are treating the water, who are managing the tailings risks, who are managing the fall of ground risk, making sure that these sites operate in the right way. Let's see. One of the things that the existence of legacy assets highlights is the importance of doing due diligence. Whenever mines go in and purchase one site, what are they getting on the back end of that? What liabilities are they acquiring as they have their eyes on the prize? What's this other thing that's sitting in the background that somebody is going to be left managing? And was that operated right? The sites that we steward, processed copper, zinc, uranium, tin, gold. None of these sites have produced anything in the last 18 years. Some of them haven't produced anything in 100 years. So it's a really wide variety. So what we're looking at is picking these things back up, picking the sites back up, and saying, are we doing the right thing with each of these? Re-examining the assumptions that went into that, the risks that are being managed at each of the sites. And looking through a little bit of a new lens to say, if we had to pick from 4 different closure outcomes, relinquishment, divestment, repurposing, and retaining, which is ongoing management of the sites in the most effective manner, which is the right option for this site, and can we combine some of those different options? Okay. And this gives you an idea of the expanse of some of BHP's legacy assets. We go coast to coast from the arid southwest of the US. We have sites, you guys may be familiar with Salmon Well Mine or some of the mines in Globe, Miami. We operate some of those. We also have sites in northern Ontario, in Elliott Lake, where we've got water, a lot of water to deal with. So we've got different environments that we're working in, as well as different climatic settings, ecosystems, hydrologic settings, and regulatory jurisdictions. So regulations for mining in Arizona look very different than regulations for mining in Canada. And regulations for mining uranium look very different than regulations for mining copper. And we're navigating all of these different sites and trying to do the right thing. One of the things, too, is they are in varying stages of closure. Some of our sites were closed 20 years ago in what was at the time considered world-class closure. There have been multiple learnings that we've shared in the past around these sites and the success stories. We haven't always shared some of our lessons learned, and I'm going to do a little bit of that today. We also have sites that, while we're managing the potential for contamination and the geotechnical risks, they haven't necessarily been closed at all. We haven't taken closure activities or closure activities. We have one site in Globe, Miami. They put in 1959, a very good closure cover on that. They put some dirt on the top and it grew some vegetation. It was world class for 1959. But that's not where we're at now. We really need to do this. And that highlights, too, the change in thought process from as things grow and as things move. It's a little bit of a target. So I talk a little bit about closure maturity and where we see closure going and how we're trying to get ahead of the closure maturity curve. We have an abundance of water at a lot of our Canadian sites that offers a lot more, offers some more social value opportunities for the local communities, but at the same time, it also leads to more closure risks, from a potential for geochemical issues, as well as potential for flooding and overtopping of dam structures. On the flip side, we've got water issues in the American Southwest, which I think we're all familiar with. Water is a very precious resource. So how can we protect that as we move forward with our thing, with our closure and with our work? Speaking of water, so in the past, the mine closure industry has really been around meeting regulatory requirements. Closure in the mining industry has been around meeting regulatory requirements. What's the minimum level of stuff that we can do to meet the regulatory requirements, keep everybody happy for the lowest cost? And looking at closure from a discounted value. You start a mine, you say, oh, closure is going to happen in 100 years. That's net present value of that is nothing. I can do whatever I want at closure. It doesn't matter. Trying to change that narrative and say, we as legacy assets aren't operating 100 years down the road. We're operating now. So all of that stuff that people wrote off as NPV, 20, 30 years ago, we're having to manage now. And how do you take those lessons that we're learning and take them back into operations and lower those costs? The next step in closure maturity, away from just meeting regulatory requirements, is managing risk. How can we do closure to manage risk in the right way? We have over 50 what BHP calls material risks within legacy assets, and they can be split into several categories. We deal with risks around water, tailings, covers, communities, soil, infrastructure, fall of ground, tailings facilities, all of that stuff. Risk mitigation efforts and treatment activities that we undertake on our sites include buttressing of tailings dams to manage that risk, treating water. There's a lot of water treatment, especially in Canada. And how do we treat and manage the risk for potential contamination? We're working on remediating contaminated soils and managing subsidence, because we've got a lot of underground mines that were never backfilled and never managed, or shafts that were capped 20 to 30 years ago, and maybe those covers aren't holding up the way we would like them to now. But if we look at this, of our risks, water comprises a lot of the risks and ends up being the golden thread that ties a lot of the risks together. It connects tailings, it connects closure, social value activities, and other risks. We have material risks around water associated with tailings facilities, surface and groundwater, storm events, dam failures, loss of containment. And a lot of our annual operating costs reflect that. A lot of our annual operating costs are managing water in one form or another. So how can we do that in the best way to ensure our sites remain safe, stable, meet regulatory and corporate commitments, and manage risk? As we progress through closure maturity, we would like to change that conversation so that it's not just about managing risk at our sites, but how are we also adding value? And now maybe that's not an economic value. Maybe we're talking about doing some positive, contributing. Instead, we're looking at positive contributions through things like environment. How can we use our closed sites to increase the biodiversity in areas? How can we use tailings facilities to contribute to decarbonization and carbon sequestration? How can we provide a benefit or a social value to the community so that they can go out and do something with these sites at the end of their life? So we're not just looking at these then as a cost to the company, we're looking at them as a benefit, just not necessarily a hard cash benefit. So today, BHP is focused on achieving optimized closure outcomes in a fit-for-purpose, site-by-site basis. With consideration, we've got a lot of competing interests. We've got obligations, we've got BHP's value commitments, we've got partner and stakeholder expectations, and of course there's cost out there, right? We always have to consider cost because we are a mining company. We're looking at how to bring in new knowledge and grow and change our closure as new knowledge comes in, with a wide array of subject matter experts into the closure planning process, and then make closure decisions that are based on BHP's appetite for risk and their appetite for contribution to social value. A couple of change stories before we get into the lessons learned. And this gets back to how things were managed, how things have been managed in the past, and how things, as new things come to light, how we change. For sites in long-term care, we need to be great managers of change because it will come to us. So we have to adapt for changing climatic conditions, events like tailings dam failures that bring refinements to best practices, changes in best practice as far as closure, stability, geochemistry, fate and transport modeling. And with a large legacy assets portfolio, we're working to prioritize what's required and how to decide where the greatest risks lie and how to manage those risks at our sites. These are a couple of examples of things that we've done in the last little while. The Miami Avenue tailings facility was in Globe, Miami, Arizona. It was legacy assets, only extreme consequence tailings facility. It was a very small one. It was only operated for 2 years, from 1920 to 1921. It contained 320 million meters cubed of tailings, but it was classified as extreme because it sat at the top of one of the main roads in the very small town of Miami, Arizona. Because, hey, it's 1920, you're just going to dump the tailings out the backside of the mill, and if people walk to work, they walk to work, you know? But due to recent changes in best practice, we went back and assessed the stability of that facility, figured we could do something easier. One of the very nice things about the Miami Avenue tailings facility is that there was a subsidence area and a pit on the backside of the hill. So we were able to go in during COVID in 2020 and pick that tailings up and essentially move it over the hill into the subsidence area, and basically eliminated that risk to the town of Miami. And we looked at different options. We looked at stabilization and the relocation because of the simplicity of the option and the constraints we had at the toe of that facility. The relocation was the best option and ended up being cost-effective as well. The Old Dominion in Arizona is the other site there. It was closed. It's an underground copper mine that operated from 1880 to 1930, during which time there were three above ground tailings facilities created. It was closed in between 2003 and 2006, and turned into repurposed as a walking park for the town of Globe, Miami. That really highlighted a lot of the history of the former mine, the exploration, some of the highlights of that. The community had a lot of value for that park. However, after the Brumadinho failure in 2019, when BHP went back and reassessed the stability of all of their tailings facilities and the risks that we managed at those facilities, we were forced to do some additional investigation at the Old Dominion tailings facilities and close at least a portion of that park while we sort out what to do there. And how do we manage the risk that the tailings facilities at that area, in that area pose? We're currently going through a project to assess stabilization, relocation, and what else needs to happen there. We're also looking, because of the historic nature of that park, looking at the geochemistry and the ongoing loading that could occur from those tailings facilities while we make the right decision. The original closure at Old Dominion cost $30 million. We're now looking at remedial estimates between 120 and 150 million for the remediation of those facilities. So I think, and it was a very hard conversation to have with the community about the closure of that part. But I think the important thing is, as we move through that and manage stakeholder expectations, external stakeholder and internal stakeholder expectations, is being very clear and honest about why we're doing what we're doing. Like, look, we're not doing this just to shut you out of the park. We're doing this to keep people safe. So, common attributes of varying closure outcomes. So what makes for good outcomes and what makes for not as good outcomes? As we optimize development and closure of some sites in the past, we've not necessarily come to the right decisions in terms of post-operation life, when we apply a modern set of optics, right? So with the value of hindsight, I'm going to present a couple of examples of some good closure outcomes and some not so good closure outcomes. The good outcomes tend to have focused on long-term thinking, robust science, good stakeholder engagement, and we generally have a greater success when we trial and evaluate design concepts in the field prior to full implementation. For poor outcomes, they've resulted in trying to achieve short-term goals of regulatory compliance, lack of consideration for site-specific conditions, particularly climatic and hydrogeologic setting, and isolated decision-making. Decision-making in a silo, where you're only looking at one piece of the puzzle. So we're inconsistent with the desires or values of other parts of the business or external communities. So here's a little bit of a success story that we had at our sites in Elliott Lake in Ontario, Canada. It's in northern Ontario, about 150 kilometers west of Sudbury, which is it's about 6 hours outside of Toronto. I don't know if anybody here in this room knows where Sudbury is, but yeah, it's about 6 hours northwest of Toronto. I've done the drive. It's a very pretty drive, but it can get long. There's a total of 12 uranium mines that operated between 1956 and 1996. And BHP acquired 8 of the mines in the early 2000s, when the sites were already in post-closure. So they'd already been closed, they were already being operated in a post-closure phase. The interesting thing about this is that the city of Elliott Lake in the 1950s was actually built as a mine town. So it was built specifically to operate these uranium mines. Uranium in the 50s was a big deal. How do we get the uranium out of the ground and increase that stuff? Unfortunately, the entire region shut down, faced closure in the mid-90s of the uranium mining industry in Ontario due to a startup of higher grade uranium mines in Saskatchewan. Towards the end of mining, there were extensive collaborative talks between mining companies, the regional communities, and all levels of government to find a new way to take the community. The community desired and was successful in repurposing the town as retirement living. So if we switch to our focus from social outcomes to more technical outcomes, the region is semi-humid climate with an average precipitation of about 950 to 600 millimeters, respectively. Oh, anyway, it's fine. The climactic region, was ideal for mitigation of oxidation of the tailings as a water cover on the tailings facility. This prevented oxidation of acid-generated tailings as well as creating a radon barrier. So we also looked at, there were also a couple of tailings facilities that were closed via vegetative cover. And we are continuing to treat water at these facilities. So all of the water, in order to maintain the water cover on the sites, water goes into the site. We, for this one, for example, water comes in at the back. It flows its way through the different ponds, is extracted from the facility here into some into a treatment plant, and then into some settling ponds before it's discharged. It works very well. It requires between 11 and 20 billion liters of contact water treatment per year at the sites, across 5 different water treatment plants. Water quality has improved significantly since 1999 when the closure was finalized. So, based on our 20 plus years of operating the sites, what did we learn? We've learned a couple of different lessons that I'd like to highlight today. Number one, as we've recently embarked on a large site characterization for the site. I think the key thing there is maintain your data and your monitoring. So we've monitored the sites for ongoing, for pollution prevention, right? We've got our wells, our monitoring wells at the site to make sure we're not, plumes aren't leaving the site. We're maintaining water treatment we're maintaining sampling at the lakes. But one thing we haven't done is update our fate and transport models. We haven't continued to take a look at the tailings and how are the tailings maturing. We haven't continued to do additional sampling of the tailings to move forward. We've recently gone in and started doing a lot of geotechnical work on the tailings and identifying that. We're also looking at updating a lot of our ongoing studies. So again, I think this comes back to some of the change in mindset from 20 years ago for mine closure and now. And the fact that once you close the mine, it doesn't stop. Things keep happening, and you have to keep up with your data and maintain a current data set for your sites. And I think that says something for operating as well. Pick up the data during operations that you might think you might need at closure when you've got the money, and you can build those data sets and sample. And make sure you have the longevity for that too, and it gets transferred to the people who are doing closure. Monitoring programs should be focused on key performance indicators with built-in triggers to support early detection of potential emerging issues and resulting adaptive management. You can't just say, okay, this is my trigger, and then I've got a problem, and what's going to happen? You need to have an adaptive management program so that once that trigger, you actually have the action plan on the other end of it to change that, to stop that from happening. And then this is a site that didn't have so good a story as Elliott Lake. As a little bit of background, this is our Selby Mine site in northwestern Quebec. It's about 130 kilometers from the nearest community. So this one's an effort to get to. It is kind of out in the middle of the bush. It's very cold. semi-humid. They've said relatively cold here, but for Tucson, it's very cold. They've got an average temperature of 0 degrees Celsius. So yeah, I'm gonna go with cold. They get 850 millimeters of precipitation and 590 millimeters of evaporation. Selby was a surface and underground copper zinc mine that operated from 1981 to 2004. And the site development included an open pit, 800 million meters cubed of potentially acid-generating tailings stored in an unlined above-ground facility, and 16 million cubic meters of potentially acid-generating waste rock that was also stored in an unlined above-ground facility. The site was reclaimed from 2004 to 2006. It included recontouring and covering of the waste rock, recontouring and covering of the waste rock dumps and tailings management area with 1 meter of sandy silt glacial till, which was what was available in the area. One of the challenges at this site was because of its remoteness, there's not a lot of construction material around, but there was a lot of glacial till. Any rock cover would have to be imported from somewhere. And then after the cover was placed, it was seeded with native grasses and legumes. The primary objective of the waste rock dump cover was to limit percolation of precipitation water into the underlying waste materials, while the primary objective of the tailings cover was to eliminate surface contact of the water while allowing sufficient infiltration to keep the tailings mass saturated. So this is another one where you're looking at a saturated tailings mass to prevent oxidation of potentially acid-generating material, while at the waste, you're looking at misaligned goals for your cover as essentially what this is. From a cover perspective, there's a couple of different issues here. The local till material was too permeable to act as an effective hydraulic barrier, and the same cover was used for both facilities with different design objectives. One was to prevent infiltration, and one was to allow infiltration into the mass. So that you're not looking at actual site-specific, facility-specific design objectives. Well, guess what? We currently have a lot of acid seepage emanating from the waste rock pile. On average, we treat about 2.2 million meters cubed of contact water, requiring 3,000 tons of lime per year to be shipped to the site. The lime that's used to treat the water at Selby comes from more than 8-hour drive away in our Elliott Lake sites. So it is a substantial addition and operating issue for us. Treated water once the water is treated, it's directed into the pit lake for polishing and prior to discharge to the environment. The good news is that the pit lake has 300 years worth of sludge storage. The bad news is that without remedial measures to stop the acid generating of the waste rock dump, we could potentially be treating water for the next 800 years. The second issue with the waste rock dump is that the landform the second issue with the waste rock dump is that the landform wasn't thought through. There is a flat plateau on the top that does not actually shed water well. They shed water, instead of shedding water via the landform, they shed water to drainages, chimney drains essentially, that were built into the waste rock dump cover, and then shed down into a pipe, under a buried pipe system. The pipe system actually has quite a bit of, this one, pipe system has quite a bit of precipitation. Because of the high TDS water that's coming off of the facility, we have to inspect the buried underground pipe on an annual basis to ensure that it still has flow because of the precipitation of the material that's coming out of the water, out of the drain system. One good aspect of the facility is that while the reclaimed waste rock pile is that while the cover was initially prone to rilling and gullying, the coarse fraction of the till material combined with the root mass of the native grasses has worked to stabilize the cover surface. So we're not getting a lot of rilling or erosion. We've got very good vegetative cover on and establishment of vegetation on top of the waste rock dump. So it did the job of at least stopping surface water from contacting the potentially acid-generating species. We are starting to get woody species beginning to naturally colonize the surface, particularly where we have water ponding on the surface of the facility. So, some lessons learned about Selby. From a cover design perspective, there are a couple of issues. Anyway, moving on, sorry. We've learned a couple of lessons from Selby over the last 15 years. Post-closure care and maintenance, and of course, hindsight's always 20/20. But what could have been done different 20 years ago when this closure was constructed? The number one, there's a potential for the plateau runoff, the landform to look differently, to shed water better, and not to rely on chimney drains and other types of conveyance that are prone to blockage and precipitation and percolation. How can you... There's always an issue whenever you're working with high TDS solutions of precipitation, or even non-high TDS solutions. Whenever you're building something that's buried, don't rely on it staying open. I think is one of the biggest messages it will require ongoing, constant maintenance. If you can design something that cannot be blocked, rely on that for conveyance of solutions. When we go to the effort of shedding incident precipitation off of a flat plateau, we want to make sure that the diverted water is conveyed off the landform in a way that minimizes the potential for this water infiltrating and percolating through the cover. This is an interesting graph here. So this shows relative closure costs at Selby over time. The green dashed line on here was the original projection of costs, relative costs. You can see the initial construction in 2004 here. The blue line is our updated actual closure costs. A few years into closure, we had to bring on-site workforce to manage the site. We had to increase our lime usage, do upgrades to the water treatment plant to streamline some of that stuff. And it really puts things into to put things into a little bit of projective. That increased our reclosure here, risk mitigation, as well as doubling our operating costs at the site. To put things a little bit into perspective, which is one of the things that is super interesting about this site, is if you look at this in relation to the revenue that was made at the Selby Mine, the original closure cost was 17% of the revenue of the mine. If we look at the updated closure costs, that's 36% of the revenue that was made. So if you start looking at your mine life, how much you're making at the mine, would you make the same decisions now that you did then if you're just going to be throwing away a third of your profit on maintaining closure of the site? In hindsight, we could have spent less money to relocate the waste rock into the pit. Then you don't have the long-term, it would have cost more on this end, but then you don't have this trailing cost, which adds up to a lot when you're looking at in perpetuity. If you move your waste rock into the pit, you don't have the potential for acid generation. It's saturated in the pit, and maybe you've got something that you need to keep an eye on, but it doesn't require the level of active management and risk. If we're shipping 3,000 tons of lime in highway trucks or in a 16-hour trip from Elliott Lake to Selby, like that's a lot of hours on the road that people are taking risks with. Now we're going to talk a little bit about a case study at one of our sites in Lisbon, Utah. And this talks about, this one involves the impacts to groundwater from 2 unlined tailings facilities at a former uranium mill site outside LaSalle, Utah. The Lisbon site produced uranium. You'll notice a lot of these uranium sites produced from 1972 to 1989. So again, right there in the high point of some of the uranium boom. It was reclaimed in the 1990s. One of the unfortunate aspects of this TSF is that they were sited on both a surface and groundwater divide. Impacts to groundwater were detected in the 70s. At the time, hey, we need uranium. It was okay. We were doing this to supply the Department of Energy with uranium that they wanted. We did put in a groundwater. I shouldn't say we. This is one of our BHP's acquisitions as well. A groundwater corrective action plan was put in place that comprised pumping and treating of the water. After 15 years of monitoring and natural attenuation, proved insufficient to manage that groundwater plume, the state of Utah, to meet state of Utah groundwater standards at the point of compliance, because of incomplete understanding of the conceptual site model is the basis for the fate and transport field studies. Over the last 5 years, we've really worked to refine the understanding that went into that site conceptual model. We've improved the groundwater fate and transport. The drawing here shows the output of this modeling effort. It also illustrates that further treatment or corrective action, the plume will affect potential receptors in the coming decades. Studies are now underway to identify technologies capable of limiting the plume migration. Feasibility studies and selection of preferred corrective actions are being worked on with the state of Utah, and a likely combination of engineered and administrative controls will be used to manage the extent of that plume. But the thing is, too, I think also gets back to the point where we're looking at having current data, having a complete site conceptual model. It takes time. And if we go from a place of not understanding to a place of understanding, it took them 5 years just to fill the gaps and understand what our problem was, because we didn't have a good idea of that before. Now it's going to take another 4 to 6 years to identify a solution, so that we're not in this space in the future, right? So some of the key lessons here are, again, go beyond the regulatory minimum. Manage your risks. Don't just do what the state tells you to do. Do what you need to do to manage your risks. Having a robust site conceptual model and refinement of the conceptual model over time. Don't just put it together and then put it on a shelf and say, oh, we've got one. No, it's cool. You have to keep that knowledge current. You have to keep your characterization of the site current, and you have to keep the analysis current to best practice within the industry. The good news for Lisbon is once we manage this issue and get control of the plume, there is a pathway for us to relinquish a portion of the site at Lisbon to the Department of Energy. it's actually required that it be relinquished to the Department of Energy because they see that as a key driver, they want to own the uranium, right? I mean, let's get down to the answer. The Department of Energy wants to own and manage uranium in the U.S. So we will need to relinquish that to the Department of Energy. Once we've met the agreed outcomes for soil, water, and final TSF configuration. And our last little case study is the Carson Hill Gold Mine in right outside of Angels Camp, California. It's an interesting little spot. This one is less about closure less about remediation decisions during closure and decisions that mine companies make that don't always put them in the best place. So BHP acquired Carson Hill whenever they purchased Western Mining in Australia. This one was divested 15 years ago. So this site was sold to somebody else 15 years ago. In hindsight, may not have been the best idea. It's in the, like I said, it's right outside of Angels Camp, California, in the eastern, in the upper foothills of the Central Sierra Nevada mountain range. It's got hot, dry summers, very wet right now. At this site, they've had about, last I talked to them, which was about a week ago, they had 18 inches of rain since November. So can be very wet in the wintertime. In 1986, the Carson Hill Gold Mining Company, owned by Western Mining, began operations in an open pit side cut to access the ore for heap leaching of the gold using cyanide extraction technology. The operation resulted in construction of 4 waste rock piles and 3 heap leach pads that are now referred to as waste management units. The open pit mining and heap leaching operations ceased in October of 1989. The leach pads were rinsed to remove cyanide and other constituents of concern. And the waste rock piles were regraded and revegetated concurrently with mining and were considered stable and reclaimed at the end of mining. The California Regional Water Control Board approved closure of the waste management units as Group C mining waste. Between 1992 and 1994, the site was closed in accordance with an approved closure plan. In 1996, a third party purchased the closed property from Western Mining. We're closed, we can hand this over, it's all good. To operate the site as Carson Hill Rock Products. The operations included mining of spent ore from the waste management units and the rock from the open pit, and creating a commercial rock crushing, screening, and aggregate washing plant. As part of the 1996 purchase and sale agreement, Western Mining retained final closure and environmental liability responsibilities for the property. That's a key statement there. And then BHP acquired Carson Hill through acquisition of Western Mining Company. Infiltration of rainwater through the vegetative covers on the WMUs results in periodic overtopping between 1994 and 2000, and again in 2006. Waters from the WMU, from the waste management units, flow into the surrounding waste piles and native rock materials, impacting water quality with elevated concentrations of TDS, sulfate, cyanide, nitrate, and certain other metals. Although the closure of the heap leach pads was approved by the relevant regulatory authorities in the early 1990s, the Water Board concluded in 2005 that groundwater at the site did not meet applicable standards and required implementation of certain corrective actions. Based on the classification of the WMUs as waste material, Western Mining was permitted to simply regrade and revegetate the heap leach pads. But given the local climatic conditions and the fact that WMUs were underlain by a double-line system, It was only a matter of time before the bathtubs underneath the heap leach pads filled up and overtopped again. In short, the original regulatory and approved mine closure plan for the Carson Hill failed and required BHP to develop and implement new closure plan through regulatory orders in the mid-2000s. BHP has been collecting and treating water at the site since 2007, as well as maintaining interim geosynthetic liners on the WMUs. However, we weren't able to do any other closure of the sites because we didn't own the site. Carson Hill Rock Products owned the site. We only own the environmental liabilities and closure, closure liabilities. So we couldn't reduce the water that we had to treat. We had to allow Carson Hill Rock Products to continue mining the WMUs in a way that suited them. BHP performed interim closure measures for more than a decade, working alongside the owner of the property to gain working alongside the owner of the property, working with him to make sure we were getting the right thing that suited his site. We were also working at the same time to reacquire that property. So we tried a number of times, unsuccessfully. The most recent and successful attempt at reacquisition took 3 years of planning and negotiations and concluded in November of 2021. So now we finally are at least own our own fate again and can take a look at that and say, what do we need to do to actually manage the closure risk and limit the water that we're treating at the site and make sure we're actually implementing a closure solution that is right for the site. This highlights two important lessons. Again, closure decisions driven by risk. We're not just trying to offload sites onto somebody else, not just divest them to somebody else to manage, because BHP is a large mining company. If something goes wrong, it's going to come back to us. We are going to be managing the environmental liabilities of the site. And again, a regulatory minimum with the WMUs. Because of the way they were, because of the type of material they were permitted to simply regrade and revegetate the heap leach piles instead of managing them and thinking through what are the actual risks from the material in that pile. And now I'm going to talk about some of the stuff, a little bit of innovation. So a little bit forward-looking. What are things that we're looking at, again, to change the way we do business to see some value from the sites? This one is highly tied to the last item that we talked about at Carson Hill. Again, we had a lot of water to manage out there. What's the best way to manage the water? It can be argued whether evaporation in certain environments is the best way to manage treated water or not. But at that site at the time, because of the limitations we had, we were looking at how to, they were relying on evaporation from the top of the lined WMUs over a limited period of time, limited evaporation window, limited area, limited access because of the work with the property owner. So we were looking for innovative ways to evaporate high TDS, high sulfate water. We trialed this technology, which is wind-aided intensified evaporation, or WAVE. It had been used in Israel quite a bit, and we worked with some providers who were coming out of there. But the units were created for water elimination at desalination plants with up to 100,000 parts per million of TDS. It's simple, environmentally friendly, has a small footprint, built-in secondary containment, and a low energy requirement. that can be paired with solar energy. So BHP performed a 3-month test with a mobile scale pilot plant of the wave unit. The technology achieved an approximate 6-fold reduction in water volume by evapo-concentration of the brine. Water testing indicates low operating cost and a simplified evaporite management. Potential for year-round evaporation. Well, maybe not when they're getting 18 inches of rain out there, but you know. In a normal winter. Maybe not when they've got an atmospheric river coming at them. And a modular design that can be expanded or moved around the site. Further analysis is ongoing to see if we can incorporate this into our current treatment ways out there. Now this is a super interesting one. This is some innovative water treatment that was undertaken at our Island Copper site on Vancouver Island. Island Copper was an open pit copper mine that was operated between 1971 and 1995, produced copper and molybdenum concentrate. After 24 years of ore extraction, the site was closed and reclaimed. A large volume of contact water required long-term collection and treatment. So upon closure, what was actually looked at was the open pit was flooded with seawater and then capped with a layer of fresh water from a nearby river. This resulted in the formation of three layers of water of different salinities within the pit, which are maintained due to their unique densities. I might have to rely more on my notes for this one because I don't always understand the science of this, but the layered structure is used to manage and remove metals from the acidic drainage that seeps from the nearby waste rock dumps into the pit. The treatment of the lake, of the water in the pit lake, is achieved through a biological process of phytoremediation. It's a low-cost liquid fertilizer is added to the top water layer of the lake year-round. The fertilizer promotes growth of phytoplankton cells, which bond with the metals and then sink to the bottom. The treated water that complies with regulatory standards flows to the top. So there's a middle layer that sits in there, which is where the the plankton work. The bad stuff drops to the bottom and the good stuff goes up. That's the simplified version. I'm not much of a biogeochemist, so. But it was pretty innovative at the time that it was installed, and it's still working today. It works very well today. There's been some improvements as far as the system that adds the phytoplankton or adds the fertilizer to the system. But it is still operating 20 years later and operating very well. And this one's a little close to home. This one's at our deep pit in Copper Cities. And one of the things we're looking at there is it's not necessarily innovative. It's not innovative, but it's an innovative way of thinking. So we've got a lot of very high TDS water. Very low pH, very high TDS water that sits in some of these pits. Instead of just treating these and discharging them or evaporating, which again, in a water-stressed environment of southern Arizona, is evaporation the best way to be managing our water? Can we extract value from the water to then take that and pay for closure or for different solutions there? We're currently undertaking some trials to evaluate the potential viability of extracting valuable minerals such as copper from our pit lakes. Some of our water, such as the deep pit Arizona, techniques to recover the copper, we're looking at, again, technologies that have been around forever. Can we just use scrap iron? Can we send this through an SXEW? As well as innovative technologies to retrieve the metals. Can we add? We're hoping that our team will have a chance to generate some revenue for the business while using that to institute some of the closure outcomes and things that we would like to achieve. And then, so some lessons learned. To summarize, based on our experience over the decades of stewarding the 23 sites, regulatory compliance isn't enough. I think you've heard that a couple of times through here. Rules change, science improves, society demands more. Be risk-based rather than compliance-driven. And if you can add social value and show the value of your sites, tack that on too. Consider the forever case throughout the mine life cycle. Relinquishment, based on our experience, is rarely realized. Consider the full cost as opposed to discounted net present value. Again, it may look good to you, but to the person who's left managing that site, it's not going to look good, and the business 20 years down the line. Identify potential closure material risks early on. It's always, the earlier you can identify the risk, the easier it is to manage. If you can manage that closure risk during operations, do that. Thinking outside the box can lead to some innovative solutions. And I can keep going. I've got a little bit of time left. I'm just going to go through these really quickly. So this is some of the, if we shift gears and talk about some stakeholder engagement that we've done. It's essential to coming up with a good closure plan, right? To showing the value, to having something that we can pass on to the site. In May of 2020, at Elliott Lake, we had a 25th anniversary of the Sheriff's Creek Wildlife Sanctuary that was celebrated. This was shared stewardship between BHP, local naturalist user group, and the city of Elliott Lake on what was once the Milliken Mine Tailings Management Area. This fulfills the vision of supporting conditions for greater biodiversity, sharing water, shared stewardship, and returning and repurposing the land to the benefits of the local community. One of the other things that we're doing a lot of as we move forward, again, this is a little bit of bringing a little bit of maturity to the closure vision and not just managing risk, but moving forward. Some of our sites ended operations 100 years ago, and it can't be assumed that that all of them have been assessed for areas of cultural significance. Closure activities include cultural heritage surveys and tribal engagements. Treatments of the sites depend on the outcomes of the consultations with the local tribes and First Nations, and may include recovery, preservation, or protection. An important element of the work includes the use of tribal monitors in the field to assess the identification of areas of significance to the tribes. It's important to invest in appropriate time to understand, be respectful, and build and maintain the relationships, and engage routinely to maximize the potential for successful closure outcomes. So don't let this be rushed just to meet a deadline. We have to build this in, and this is a very important aspect of closure, doing the right thing and working with the communities and the cultural heritage groups. Closure is multidisciplinary. It covers everything. Throughout the life of planning, execution phase, it's important to note that closure planning is a process. It's not an event. It's not something that's one and done. It's something that you do throughout the life and then you do through post-closure to ask yourself, are we still doing the right thing? Have conditions changed? Or should we be doing something different? Has the community changed? Has the technical knowledge base or best practices changed? And over the years, Legacy Assets has required a lot of expertise in various parts of closure. We've got people from geotechnical engineers doing responsible tailings facility management. We've got work with corporate affairs and legal a lot. We've got people on our team who go out and construct things in the field. We've got people who turn water pumps off and on. We've got specialists. We're working with specialists within BHP's innovation team, commercial agreements, regulatory permitting. It's wide. It's all over the place what we do. And for some closing remarks. From a technical perspective, using robust science as well as performing proofing concepts in the field are two factors that lead to much higher probability of success. Climate change predictions need to be part of base case analysis during design, not part of sensitivity analysis. Water is the golden thread that ties all major closure elements together. If we didn't have water, where would our issues be? But then, we wouldn't have water. We would have issues surviving. Continual integration of knowledge and collaboration with SMEs early and often is what we're talking about whenever we talk about collaboration and knowledge sharing. And work with internal and external stakeholders. While relinquishment is a great aspiration of our mine sites, we should develop a plan for each domain and carry out investigations, assuming that we're going to be stuck with these sites forever, for a very long time. We have far greater chance of relinquishing properties if we make our decisions around risk-informed. We can reduce the amount of operations that's required to maintain those facilities. You're going to have much greater chance of relinquishment. Maybe not in the U.S. I still don't think we're ever going to relinquish anything in the U.S., but in different environments. When evaluating different closure strategies for the site from a cost perspective, undiscounted total closure cost provides a better assessment of total dollars projected to be spent over the life of the asset. If we select closure strategies based on NPV, we are going to favor strategies that offer the least number of opportunities to build social value and manage our risk. Leaving the site and the owner exposed during the post-closure life of the facility. And lastly, we've learned from opportunities for building social value dramatically increase when trailing environmental liabilities are robustly addressed. So that's it. I'm available to have questions if you guys have any of that.
All right, thank you, Clara, for the great talk. Now we will open the floor for questions, if anyone has. Not all at the same time. Well, I do have one actually.
Yeah.
It seems like BHP is acquiring some properties, right? But they are not necessarily mining them.
So
and I'm wondering, what are the incentives behind that?
It's not that they acquired these properties. They acquired another property, and these tagged along. So for example, BHP Copper, our sites in San Manuel, Globe, Miami were acquired whenever BHP acquired Magma. And they got Escondida with the Magma operation. Western Mining, they acquired Olympic Dam. They also got Carson Hill. So this is what I talk about when I talk about due diligence. And mining companies being sure of exactly what's in the portfolio of the mining company that they're acquiring. Because they could have this big shiny mine over here that they're looking at, but they've also got this liability that sits over here that nobody wants to show you. So it's very important when you talk about due diligence and mines acquiring other mines to look at the entire portfolio of the mining that the company that it's being acquired.
Thank you.
Yeah, no problem.
All right. Dean first.
So my question involves technology. And what technology do you foresee in the immediate and midterm future to help mitigate and handle your risk management process?
You know, we've been talking through things like I know BHP sponsored things like the Tailings Challenge, and how can we repurpose our tailings and use those sorts of things to mitigate risk. To me, I don't think we can rely on technology, on new technologies to mitigate risk. If it's a risk in the field right now, it's something we have to mitigate with technologies that we have, that are known technologies. Depending on what the risk is, and I don't know, maybe I'm hesitant because we talk about things like repurposing tailings and turning tailings into aggregate or turning tailings into fertilizer. And a lot of these facilities, and admittedly I come from a tailings background, so I'm going to probably talk more about tailings than maybe geochem and some of the other stuff. But Solitude, one of our tailings facilities in Globe, Miami, it took 30 years to place that facility. San Manuel, it took 50 years to place that facility. We're not going to rely on a technology to repurpose these at the same rate that they were produced. So if it's really a risk that we need to manage in the short term, we need to rely on existing proven technologies and then use future technologies as a bonus for the future. To say these are things that we can add on, we can maybe recoup some of our costs in the future on this, but I wouldn't use them to manage risks. Does that answer your question? Am I seeing where you're coming from, or did you have something in particular in mind?
It's good for now.
Okay, and I can always chat.
I'm just curious, what are some of your common roadblocks? So you're trying to make improvements to these 23 sites. Are there certain things that always get in the way to progress to those improvements?
In the past, part of it's business case, right? So there's been a lot of growth and support for closure in the last 4 to 5 years, even within BHP. So our group has expanded significantly in the last 4 to 5 years. When I joined, there wasn't a planning and technical team. There was a geotechnical team and 2 geotechnical engineers that were managing tailings facility risk across all of those 23 sites. We now have a team of, how many people do I manage now? 20 to 25 people who are doing that job, who are categorizing our risk. So I think one of the roadblocks has been support. And being able, and that's why I think one of the valuable things is how we change that narrative around closure to not just be managing risk. It is what is the value that is intrinsic to these sites, and how if companies are going to set ESG goals for themselves around environment and social, how can we leverage these sites to get that support from mining companies, to show them the value? You're not just paying this operating cost at Selby to treat lime. That's not all that you're getting out of it. You're getting biodiversity, you're getting some of these other social, non-economically quantifiable benefits.
So I have a question about, is the reclamation predictable? And before you decided to start a mine, will you consider reclamation as a key point, like to decide where you start the mine? And as you mentioned, like there are a lot of problems. Like for example, you mentioned about Solitude, like being like 30 years. Will you consider those into it? And also the Cousin Hill, you mentioned about it. You got a plan, but it failed, right? Will those all be considered into it? Like how long it will be, like also how much money we will put it into it in the future, like those. Yeah.
It depends on who you ask. I think it should be considered. And one of the things that's been pushed for a lot recently is as you look at some of the mine plans that are going forward, that are going into feasibility studies and things like that, you're looking at things like concurrent reclamation. How do you build reclamation during the life of the facility into the plan for the facility? And one of the nice things about that too is you can test whether your closure solution works if you do it during the operating life of the facility. So we've got this plan. We're going to do this with our waste rock dumps. We're going to do this with our heap leach pads. This is how we're going to do our water treatment. You can test that during the operation. Let's institute this on a portion of our facility. Is that working? No. Let's plan something else. I do think whenever you look at the inclusion of it into mine plans, into conceptual pre-fees and feasibility level documents, I think to be truthful, it's going to come from the investors. That's what's finally got the push for the focus on tailings facilities that it has. I think it's going to take the investor saying, no, you have to include this in your feasibility design. We want to see this. Where are the mining companies getting money from? People have to vote with their money. But I do think it should be included, and I think mining companies should be looking at something like that.
All right, thank you. Another question there?
So are you looking at the possibility of a site reopening when you're making your closure plans, and would that affect the closure plans and how you choose to handle it?
Yeah, one of the challenges, we do keep that in the back of our mind, and I think one of the things, whenever you have a closure plan, you can't bet on that happening, right? So you have to keep an eye on things like decision trees. If we get to this point, what needs to change? They were closed for a reason. What needs to change so that we could go into something like reopening? Does the ore price, what price does the ore need to get to before what price does copper need to get to? What price does gold need to get to before we look at reopening the site? One of the interesting problems we're looking at right now is things like mining our waste facilities for other things. How do we recover rare earths? Can we get copper out of tailings facilities? Is there still gold in some of the waste rock dumps? The challenge that we're looking at is whenever you look at a resource and reserve for those sorts of things, how do you develop that for something that doesn't have any geologic control? We don't necessarily know how the material was placed. I don't know where the high grade is in that leach pad out at Carson Hill. I can't do a proper characterization of a resource and reserve for that. So how can we do that and show the value that sits in our waste rock dump? And I don't necessarily have the right answer for that right now. Everybody always asks us about rare earths in our tailings facilities. I can tell you based on 2 or 3 samples that yes, there might be rare earths in the tailings facilities, but how can I quantify what that is worth? So.
Okay, are there any more questions? If not, I would like to thank you again, Clara, for this nice talk.
Yeah.
And I think we can continue the discussion around some refreshments and some food outside. Thank you all for coming, and see you next month.